The fixed point iteration method, explained without an example, is very hard for you to visualize what's going on. So I invite you to look at an example first and then reread in your notes. You can download this, reread the procedure, because it's going to make much more sense once you have a perception of what it means based on a real life situation, on a real function. Okay. Anyway, I'm going to try to go over and then compare with the example I have over here for you to understand what these instructions mean. Anyway, I try to use here a color scheme that is going to be applied to the example for you to know what each step corresponds to. All right? What is the main idea over here? First, if you don't have the equation put in the form fx equals to 0, do that first. All right? You may have the function being part of it equals to another part of it. Just bring everything to one side and equal it to 0. Then the next step is to extract an x out of that function and leave it on one side of the equal. Let's look at the example to see what this means. Eventually, you need to get from this function, transforming it into something like this. So let's say that the original function that you have on a paper was this. So the first step is to rewrite it like this, equals to 0, right? You don't have to do the sketch, but I did here anyway for you to understand and conceptualize what this process is all about. So it will be a cubic just like this. Second step, isolate x on one side so that it turns into x equals big F of x. In this case, I picked to keep this or send this minus 5x over to that side, and then the 5 back over here. So I would get this, x equals x cubed plus 3 divided by 5. Notice that this and this, they are the same, right? But now this part over here is going to be your new function, big F of x. And what am I doing conceptually over here? I'm equaling two different functions. The first function is the function y equals x, and the second function is a function y equals x cubed plus 3 over 5. So instead of having this is this, I have now this. I have the function y equals x over here, the straight line over here, equals this one, which is another cubic. And I'm trying to, by setting it up the way it is right now, I'm trying to look for the points of intersection between these two. And if you pay attention, you'll notice that the points of intersection, the x-coordinates of the points of intersection of these two, are going to be the same as the zeros of the original. And this is the main idea that I want you to retain. The idea of rewriting this function as x equals the rest of it, and by the rest of it, I mean whatever is not x, the x that you picked, and figuring out the value for this equality, that is the point of intersection or the points of intersection between these two, will allow you to get literally the zeros of the original function, which is the whole purpose of this endeavor, right? So once you have this, what is the next step? 3. Now that you have this, this will be the base for the iterative formula that will sometimes rapidly converge to the root, and the iterative formula is this over here. So that's x of n plus 1 equals f big F of xn. So you are going to transform now this into the iterative formula, which is this, all right? The idea, again, I promise you that the idea is much simpler than it might look just by looking at this, all right? And because now you are going to use the calculator to figure out an approximation to the zeros. Let's see how this works. You are now over here. Now 4. Use the iterative formula to calculate a few values. If these tend to a specific value a, then a is a fixed point, and the root of the original equation f of x equals 0. If not, you cannot use the method, all right? And what values are you going to pick? This is what is explained over here. So this is the procedure. Pick a value x1, that is the first value that is arbitrarily close to a. Particularly if you have a graph, you will try to start with a value over here that is arbitrarily close to what you think this value is. So you may think that this value, maybe this is 1.5. So I'm going to try 1.5. All right. So look at the value again. 1.5. And sorry, let me just follow the rules. Pick the value, then find f of that. All right. F of 1.5. Don't forget what this f is. This f is this. So you basically put 1.5 over here, cube it minus 3 over 5, and you get this, 2.119. All right, let's continue. Then this is going to be your next value that you're going to try, your x2. So what are you going to do? You are going to do f of x2. So f of that. Now, instead of writing 1.5, you are going to try that. Plug in the formula. So 2.119 cubed minus 3 divided by 5. And you get this. 9. Apparently, it's not converging to any point. But let's try again. Now, this is going to be your next point. Plug it here again. So do 9.144 cubed minus 3 divided by 5. And you get that value. Obviously, this is not converging, right? Started with 2 point something, 9 point something. Now you're already in 1,279. So obviously, it's not converging. It is diverging. So the original point that you picked did not yield any significant value. Let's try another point. Let's try this one over here, 1, and see what happens. So now we're starting with 1. So do f of 1. 1 cubed minus 3 over 5, that's 0.8. It's more promising. Now, let's try it with 0.8. 0.8 cubed minus 3 over 5 is 0.6655. Okay. It's not going out of the way of the original value, right? Let's try now this value, and you get 0.6261. Okay. Try it again. See what's happening here? This is converging. Every single value that you get is going to be your next point that you are going to try on the function f, big F of x. As simple as that. And see what's happening? This is converging. You can already be sure at this point that the value 0.6 is correct to one decimal place. But if you continue doing this, automatically you are going to increase the precision. Then I continued over here, x7, x8. Look at the values. You got as precise as 0.6180, precise to 4 decimal places, just continuing doing this process. All right. So again, I invite you over here to use the calculator to write down the expression. Let me see if I still have it here. Where did I put it? I don't have it. Here it is. You might, this was for a different question, but you might just write down the expression that you have over here. And this was e to the power of x minus 3 times x. This is already from a question that I solved, and you will find on the course, okay? And the value that I'm changing is the 0.6, all right? So next time I may want to go to 0 and plug in this value over here. And then the outcome you plug in over here. Basically, what I mean is that you leave the expression on the calculator and you just use the cursor in a calculator to change the value of x for the new value of x. And every result that you get here is the one that you plug over there. So you are going to continuously look at the calculator to plug in each new value that you get on the calculator and you just have to write down your result. You still have to show you're working out, so you need to write down the values that you get, all right? But you don't need to do anything more fancy than that, all right? I want you to pay attention to the reason why the first result didn't get any, was diverging, wasn't getting anywhere, and the second one was. Let me just put this a little bit smaller. The first one corresponded to this. You tried here a value, okay? A value of x, of f of x, equals to x, right? Now this is going to be your new value that you are going to try, x2. So f of x2 is this one over here, okay? That equals to x. Now this is going to be your x, this should be x3, your value x3, and this is going to find this one just in 1200 or something, as you saw it a while ago. So this is diverging, it's not getting any value. But this one is. If you try now this value, x1, it was 1 a little while ago, what is going to happen? F of x1 is this one over here, is this value over here, right? It's going to be your next x. It's going to be your next x. Don't forget that this is a line y equals x. So it's going to be your next x2. This x2 is the result of f of x1, right? And what is it going to be? It's going to be this result. You are going to try it over here. And what is happening over here? As you can see, this is the procedure that is taking place. You are getting closer and closer and closer and closer to this. And this over here is the value that you want. This over here is the root of the original equation before you separate it into x and big F of x, right? Before you separate it into this is the value that you had over there, all right? There are other situations in which instead of having this stairway diagram for you to get the value of the root, you have something like this. This is called a CAIE diagram. So you would start with this value over here, f of x1 is this, then equal it to x is going to be the value for your next attempt. So f of x2, you have this, try it over here, f of x3 is going to be this, equal it to x of f4 is this, equal it to x, and you continue, and you are narrowing down the search until you get to whatever level of precision that either the question or yourself has predetermined. Note that different starting points and equations may find different roots. In most situations, you are going to be given the equation that you start with, so you don't have to worry on trying to figure out the right one that would yield you the result that you want.